Alright, this is standard form, chapter 8, section 1. Your objective today is that you'll be able to identify characteristics of quadratic functions and graph. To start off with, we're going to kind of be talking about a few characteristics of quadratic functions. The first thing that we're going to talk about is we're going to talk about a vertical shift, or stretch, sorry, vertical stretch. A vertical stretch makes things so that it's skinnier. That's kind of the way to think about it. And the way that we can identify those is when our a is greater than 1. And we're specifically talking about when it's in the form ax squared. And so when our a value, this value right here, when that a is 1, is greater than 1, it's going to make it skinnier. It's going to have this what we call a vertical stretch. A vertical shrink, and kind of using some of your logic here, shrink, if a vertical stretch makes it skinnier, then a vertical shrink should make it wider. And if a vertical stretch is when a is greater than 1, a vertical shrink is when a is less than 1. But not just when a is less than 1, it also needs to be greater than 0. And we'll talk about how it could be less than 0 and what would happen there in a little bit. The next thing that we have is a vertical shift. Vertical shift. Now, a vertical shift is different. These vertical stretch and shrink, you're kind of changing the shape of the graph. And this vertical shift, it's moving the graph. And specifically, it's moving it vertically, or in kind of other terms, it moves it up and down. The next one that we have is a horizontal shift. Horizontal shift. And as you can probably guess from kind of the name, this makes it move left and right. Okay. And there's a couple other characteristics that we kind of need to know about. If I have a little, wow, that was a really bad graph. If I have a graph over here, and I have a parabola like this, what we kind of want to do is we want to read left to right, kind of like you're reading a book or you're reading some text. And what we're kind of looking at is we're looking at how the parabola is behaving. And so as I read from left to right, I start going and I say, hey, this is coming from above. It's decreasing in its value. And that's important. It's decreasing in value until it gets to a certain point. And this point, or this place, is what we call the axis of symmetry. And that axis of symmetry coincides with the vertex. And so that kind of all happened in one place. And so I'm reading left to right. I have decreasing, decreasing, decreasing. I hit this axis of symmetry. I hit the vertex. And then my graph starts doing something else. It starts increasing. It starts going back up. So a few things that we're going to do kind of real quick is we're going to compare some functions to a graph of y equals negative 5x. Now, a graph of negative 5x is going to look something like this. So I'm going to have a little graph here. And I told you we were going to kind of talk a little bit about what happens if our number is less than 0. And you can kind of think that negative 5 is less than 0. And so this one actually goes right here. And the first one, 2, 3, 4, 5, goes here and here. And what that negative does is it makes it go upside down. And that's the only thing it really does. The other things about it still stay the same. It's still a vertical stretch or a vertical shrink. So let's do some comparisons. So number 1 has y equals 5x squared. And so how is that different than, I'll put the parent function up here. Maybe I'll put it in blue. Y equals negative 5x squared. So you should be able to look at it and at least say, okay, the difference is it doesn't have that negative in it. And so what that makes it do is it makes it open up. Kind of like a little smiley face. That's how I like to remember it. And then number 2. Number 2, we have y equals negative 0.5 x squared. And so I have to think, all right, is this greater than 1? Is it less than 1? And what's kind of happening? And really I'm kind of basing it off of this specific thing that we kind of already did. I'm basing it off of that. Is it less than it or is it bigger than it? And when I think about it, I go 0.5 is less than 5. The negative doesn't really play a part because the negatives they both share, and so they're both facing down. And so I'm left with 5 and 0.5. And I think, which one's bigger? Oh, the 5 is bigger. So what that makes this is this makes this a vertical shrink. And then for number 3, I have the same thing. I have y equals negative 0.00 x squared, or 0.5, there we go, x squared. And this is also a vertical shrink. I'm like, alright, I think I got that. And so we kind of go to the next one. And what's really cool about parabolas is a lot of times we can see these kind of a little bit more real world than some lines. And so number 4 reads, the arch support of a bridge can be modeled, let me pull this up, by y equals negative 0.00125 x squared, where x and y are measured in feet. The width of the arch is 800 feet. Describe the domain of the function and explain. So the width of our arch, or the kind of the width of our bridge. So if I want to draw a little picture, and I find that drawing pictures really makes things kind of a lot easier. And so if I have that bridge, really the arch, the bridge, and I say that the grand total of this whole entire arch is 800 feet. And I want to find the domain of the function. Domain is our x value. And kind of a thing that we need to kind of look for is we kind of are looking at this and saying, is there anything kind of really changing about it? And the only thing that I really notice is that this a is less than 0, or less than 1, sorry, and it's upside down. And so there's nothing really trying to change about this. And so what I can say is that my range, or my domain, my x values, and I'd really have a graph that goes right, see if I can make it do it, right along here. My graph goes, and I didn't center that very well, sorry. My graph goes from negative 400 feet, that's less than or equal to x, and it's less than or equal to 400. And what this does is this has our axis of symmetry splitting the width in half equally. So the axis of symmetry splits the width in half equally. And that's actually really important in engineering. We don't want something to have kind of be carrying more weight, otherwise it's more likely to fail. All right. Okay, so the next thing that we want to look at is the y-intercept of the graph y equals ax squared always 0? And the answer to that is yes. There is no addition or subtraction occurring. All right. Hopefully you get it. Have a good one.